Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. This is our lecture number 2 of CT253 Mechanics of Structure. Today we are dealing with the stress and strain numericals. In this lecture we include two numericals. First one is here, numerical number 1. A metal wire is 2.5 millimeter diameter, and we have made here a given data. Diameter is equal to 2.5. D for diameter, D is equal to 2.5 millimeter, and 2 meter long. The wire is 2 meter long, so the length is 2 meter, and we have converted this 2 meter into the millimeter by multiplying 1000, and this is the 2000 millimeter. A force of 12 Newton, is applied to it, and it stretches 0.3 millimeter. Due to this force, the wire stretches 0.3 millimeter, and the length 2 meter increased by 0.3 millimeter. Determine the following: stress in the wire and strain in the wire. For these two we will work. To find the stress or strain, first step is to find the area of the cross section. So for this, as the wire is circular and having a 2.5 millimeter diameter, we are using area is equal to pi upon 4d square. This is the formula, and in this d here we are putting 2.5 mm, and when we simplify it, we are getting this result 4.909 millimeter square. After this, we will able to calculate the stress. We know that F is stress, this capital F is force, and A is the cross-sectional area. F is given 12 Newton, you can hear, and area we have calculated 4.909. We will divide 12 by 4.909 and getting the 2.44 Newton per millimeter square stress. This is the strain. The strain is the change in length or stretches in length divided by original length. This is the formula, and we are showing stretches by X and original length by L. X upon L is equal to strain, so X is equal to 0.3 mm is given, 2000 length millimeter is given, divide, and we are getting the result 0.00015 strain. Strain has no unit of measurement. This is the numerical 2. A steel bar is 10 millimeter diameter, so D is equal to 10 millimeter, and the 2 meter long, the length is 2 meter, here 2 meter, we are converting it into millimeter and getting the 2000 mm. It stretches with a force of 20 kilonewton. Force is 20 kilonewton. We are converting this into the Newton only. K for 1000, so K for replace 1000 multiplying by 20, and we are getting 20,000 Newton force, and extends by the 0.2 mm. The stretches is 0.2 mm, so calculate stress and strain. This is the calculation step 1. We are finding the area of the cross section. A is equal to pi d square by 4, and here is the diameter is 10 mm, so we are putting the diameter 10 mm, 10 square multiplied pi divided by 4. We are getting the cross sectional area is 78.5 mm square. The next step is the stress, and stress is equal to force upon area, and force is 20,000, and area we have calculated 78.5. We are getting 254.77 Newton per millimeter square stress. For strain, As strain is equal to change in length, stretch in length divided by original length. So stretch in length is 0.2 mm. We are putting here 0.2 mm. Original length is 2 millimeter or 2000 millimeter, and 0.2 divided by 2000, we are getting 0.0001. Strain has no unit of measurement. This is the assignment. A rod is 0.5 meter long and 5 millimeter diameter. It is stretched 0.06 mm by a force of 3 kilonewton. Calculate the stress and strain. Thank you very much. Assalamu alaikum wa rahmatullahi wa barakatuh.